Welcome back to my workshop. Now today I'm not going to be making anything. What I'm going to do is look at this. Now this has been given to me to look at because it doesn't work. What is it? Right, this is a Makita DUH523 Hedge trimmer. Okay, and it just doesn't work. You pull the button, nothing. Okay, so what we're going to do, I'll quickly show you over this. I can't tell you whether it's any good or not because obviously it doesn't work. But what we're going to do is we're going to strip it apart step by step. I'll show you how it works inside and then hopefully we can find out what's wrong with it. I don't know if I'll be able to fix it today, but I'll be able to find out what's wrong with it. So let's have a close look. Right, so having a quick look at this now. This is the DUH523. I believe it's a DUH523Z. But they don't put a Z on here, but if you refer to anything, this is the Z. Simple Makita, normal blue colour. You've got your trigger here with a safety, okay, pull the trigger. You've also got another safety here, so you have to be holding this and pushing this button before it will start. Okay, very much like a chainsaw, but that's a good safety feature. 89 dB, so not too loud, but you're in the garden anyway. This is on the Makita battery platform. Okay, this comes with a 5 amp hour battery, 18 volts. Okay, won't go into any detail with that. But as I say, this doesn't work. What else have we got here? We got a shield here. Okay, this will have to come off, this will have to come off. And obviously it's got a standard hedge trim and type blade. As I say, this is not a product review. What we want to do is find out why this doesn't work. So the very first thing we need to do is find out if there's anything in the battery. If it's got a flat battery, it's not going to work. So let's check the battery. Now obviously, if you've got other Makita tools and you're already on the Makita battery platform, the simplest way to check it is by taking this and plugging it into something and just seeing if it works. I'm not on this battery platform. I tend to be on a Stanley platform. So I'm going to have to check this and I'll check it with a voltmeter. Right, it should be a fairly simple process. If we look at our battery here, we've got battery positive here, battery negative here. We treat this like any normal DC battery. The voltmeter I got is this one here. Now this is quite an expensive voltmeter. It's a Fluke. But any voltmeter will do, as long as it works. Let's get this so you can see it. Okay, so this is a DC battery. So what I want to do is set my meter to DC, which is this little fella here. Okay, now what I'm looking for on here is something in the region of 18 or 19 volts because that's what it says here. Okay, I've got my two probes, red and black. Red is obviously positive, black is obviously negative. And all I'm going to do is probe this terminal and this terminal, 19.38 volts. Okay, so I'd be quite happy to say the battery seems okay. Now that's just an indication of the voltage. It doesn't tell me its capabilities for current, but I'm suspecting that's going to be okay. That's enough about the battery. Let's get onto the body of the machine. Right, so the first thing I'm going to do, I don't need to remove this guard for now. Plus as well, I don't want to cut my fingers off. So the first electrical check we're going to do is on here, which is obviously where the battery slots into. Okay, you've got two terminals here. You've got a smaller terminal, but we're not worried about that at the moment. So we've got our two terminals here that marry up with the positive and negative on the battery. So what we're going to do is we're going to check across these two, pull the switch and see if we've got continuity. Okay, I'll explain what that means in a minute. But what we need again is we need our meter. Okay, but this time we need it set on resistance. Okay, so this little ohm sign here. Let's get this in closer so you can see. This little ohm sign here. So we're on resistance. Okay, this is not going to get too technical, but basically what it means, if you look at this where it says OL, okay, let's open load. If I touch my two terminals together, okay, it gives me a very, very, very low number. Okay, that means there's continuity. In other words, this is touching that electrically. Okay, and what I'm going to do is I'm going to touch it across these two terminals here, pull the switch, and I should see a complete circuit through this machine. Okay, I'll draw you a picture in a minute so you don't have to think about it too much. But what we need is to plug that onto that side. I've lost my other terminal. Let me just go and find my other terminal. Okay, I found it. It was hiding under a piece of rag. Okay, so I connect that onto that connector. Right, there's no power here now because I haven't got a battery on. But what I'm going to do is pull the switches. Okay, so this switch and the main trigger. Okay, and when I pull them together, this should go to 0. But it doesn't. It goes to 200 kilo ohms. Okay, so that means there is a circuit, but I suspect it's not going through the motor because it's a high resistance. Now let me draw you a quick diagram. You don't have to be an electrical expert to understand this diagram. I'll explain it. Okay, this is not going to get complicated. I'm not going to ask you any questions. It's just so you understand what's going on inside the hedge trimmer. Okay, so basically we've got our battery, which you have already seen is okay. Okay, this is our positive, this is our negative. And all it does, it goes through 2 switches and a motor. Okay, so basically one switch, which is the finger trigger, and then it goes through another switch, which is the front grip trigger. Okay, then this goes to a motor, and then this returns to the battery. Okay, that's the entire circuit as far as we're concerned. We're not worried about any other protection or voltage stabilization or anything like that. We don't care about that. We just want it to work. Okay, and the idea is if I pull this switch, it closes that part of the circuit, but it still won't work. But if I pull the second switch, okay, on the handle, okay, you've got a complete circuit, goes all the way through. Okay, so the current goes this way. It makes this motor go like this and spin round. Okay, and the current returns to the battery. That's all we need to know. Okay, we've checked the battery. That's okay. So we'll get it open and we can check this switch and the motor. Right, that's enough of the school stuff. Let's start taking stuff apart. Right, as with most things you buy today, they're made on a production line, they're made fast, they're assembled quick, which means most of the time you can disassemble them quite quickly as well. Okay, so that's what we're aiming to do here. We're going to disassemble it quite quickly. What we need to do is get this cover off, okay? But we can't get that off because we've got a shield here, or we've got an arm here, and we've also got this shield. Okay, so what we'll do is we'll start here, we'll take the shield off, which is just a couple of screws. Right, I'm hoping I'm going to be able to get all of this apart with just this screwdriver. Okay, so to get this cover off, turn it over. We've got one screw here and one screw here. Let's get those out. And then this just pulls off like that. Okay, before anyone says anything, yes, this is the wrong screwdriver. I should have had a slightly bigger one. Now, as with all things like this, as soon as you start taking them apart, you need to put your screws somewhere safe. Okay, my standard go-to is a Chinese container. Okay, so have a quick look at these screws, make sure you can identify them later because you need to put them back and then put them in there. Right, the next thing is getting this handle off. Okay, it looks like it's held in by one screw this side and one screw this side. Okay, and what I'm going to do is I'm going to get a proper screwdriver this time. Right, so at the minute, obviously we know this activates the switch, but we don't know how. So we don't know if there's any electrical cables in here. But you've got to remember it was made on an assembly line, so they're not going to want it to be too fiddly. So looking at it, I suspect pull it apart and then push it down. Okay, it's as simple as that. Okay, so there's no electrical connections in here. All you've got is a lug on this side and one on that side. So I should imagine they move a lever which pushes a switch. Right, not worried about that because that's mechanical. Right, the next part is getting this side cover off. Right, I've had a quick look here and there's 1, 2, 3, 4, 5, 6, 7 screws. This is just a hole. Okay, 7 screws and then this should come off. So let me get those off. Okay, looks like the one at the front is a main one, which is quite long. Okay, that should be easy enough to identify. Right, let me just lift off this plastic cover. That was easy enough. All right, let's have a look inside. Right, so this is the basic anatomy of a DUH523 Makita hedge trimmer. Now what we've got here is, this part here is where the battery mounts to. Okay, I won't plug it in just yet because we've now got exposed wiring. You should be quite safe, but you don't want to be chopping your fingers off. Okay, we've got the wiring from the battery comes here to the first switch. Okay, this is the finger switch. Okay, then it goes off to this second switch, which is the one on the main paddle at the front. Okay, and as I showed you earlier on, this has got a little lug here. Okay, and what that lug does, it sits in here and does this. Okay, so it moves that, which pushes the switch. Okay, so this switch needs to be switched, this switch needs to be switched, then it sends the voltage to here, which is where the motor is housed. Okay, so in here is the motor, and then down here you've got some gearing, which turns the turning motor into linear motion, which makes the hedge trimmer go like that. We don't care about that. Okay, first thing you're going to do is check this switch. Okay, there's a little picture on it which should help us, and it shows you NC, NO and COM. Okay, and what that is NC is normally closed, NO is normally open, and COM is common. So if we check between the common and the normally open and then pull this switch, okay, we should get continuity. Okay, what I'm going to do is I'm just going to pull that off because it's got a little spring and I don't want to lose it. It can go in our bucket. Okay, but I can push a switch here. Right, so let's get our voltmeter and go between these two terminals, okay, and see if we've got continuity. Okay, I brought you in close here so you can see. Let me try and point some things out to you. Okay, so what I'm doing is I'm going between the common, okay, and the normally open. Okay, so when I push this switch here, these two should join together and this voltmeter should go to something like 0.001. Okay, so let me just mount my camera. Okay, watching this, push this button, 0.00.1. Okay, that's fantastic. So we know that switch is working fine. Okay, what we want to do now is check the other switch down here and do exactly the same again. Okay, I've pulled this switch out so you can have a closer look. I'm going between the common and the normally open connector. Now make sure your probes here don't touch together because you'll end up with a false reading. Okay, and again we're looking at this. Now it's showing a high resistance at the moment. I think this switch is slightly different than the other switch, but it's a high resistance which is effectively an open circuit as far as we're concerned. So push the switch, okay, 0.000.2. Okay, so it's a very low resistance once it's shut. Okay, so we know that this switch is also okay. So that's okay, that's okay. It looks like we're going to have a look at the motor. Right, so we need to get to the electrical contacts on the motor here, but this is obviously encased in this plastic, but you can't get this cover off until you've got this cover off. Okay, so this is 4 screws on the bottom, and this should start showing the gears. Okay, so let me get those off. I might cheat with this and use this. Right, let's get that off. Still got the 4 screws in it. Oh, it's a bit greasy under there, look at that. Okay, all right, don't lose the screws, put them in your case. All right, so this is obviously the horrible greasy bit, which we're probably going to have to remove before we can get this cover off, because otherwise all bits will fall off here. So it looks like it's just these 4 screws, 1, 2, 3, 4, okay, and then the whole bar should come off. There's a teeny tiny washer here, okay, whatever you do, don't lose that, it's a spacer washer. Okay, let's get these off. Right, so I'm hoping now that this whole unit is going to lift off. Oh, well that was easy. Okay, so don't lose this washer. Put this to one side. Careful where you put it because it's a bit greasy. Alright, that exposes this gear. Okay, this gear meshes with the motor here. Okay, so it's a direct drive from that to this big gear. I'm hoping this is just going to pull out, which it does. No springs or anything. Make a note of which way this goes. Okay. Right, okay, that's clear. And there's another washer here, so don't lose that. Okay, again, put it somewhere safe. Okay, so the inside, the bit where it dips in, goes on the inside. That's what we've got to remember. All right. Ugh. All right, the next step is to get this plastic cover off. There's a couple of rubber grommets here, both the same size. Okay, they go pointy side down. Remember that. Okay, screws, 1, 2, 3, 4, 5 screws. Okay, let's get those off. Okay, and then hopefully this cover should lift off. Oh, there's a rubber grommet on the top here, which holds the 2 casings together. Okay, so pull that out of the way, and then that lifts off. Okay, that's the outer cover. So now we can actually see the motor. Alright, so now we can actually get to the motor. If you look on the top here, it's an all DC motor. So you've got 2 electrical connections, okay, 1 positive, 1 negative. Okay, if you look on the positive, there's a little red dot next to it so you know which way it goes. Okay, what we want to do is find out whether, when you push this switch and that switch, whether you're actually getting any voltage to the motor. Okay, so this involves putting the battery on and connecting to these 2 and pulling the trigger to see if we get voltage here. Right, so being very careful. I've now got the battery back on. Okay, get my voltmeter again. Get it so you can see it. Okay, 0, 0, 0. We're now back onto voltage. Okay, volts DC. Get my first terminal onto the negative. Okay, that's the black one. And my next one onto the positive. Okay, again, make sure these don't touch each other because you could end up making little sparks. So if I push this switch, nothing happens. If I push this switch, nothing happens. But if I push them both at the same time, 19.4 volts. So we know when we pull both these triggers, okay, we're getting full battery voltage to the motor, but the motor is not going round. Right, let's see if we can look closely at that. Right, so we need to pull the motor out. So what I'm going to do is take the battery off again. We don't need that on there anymore. How does this come out? Okay, I suspect this is going to get very greasy. Oh, here we go. All right, so that just lifts off, which is fair enough. We've got a bearing here in this casing. Now, will that come off? Okay, that's just a little press fit. Okay, don't lose this washer. So the bearing sits in here, and then that sits in that plastic housing. Right, so we've got the bearing off. What we need to do is now electrically disconnect this. Okay, so it's just a case of pulling the 2 terminals off. Now this is obviously why you disconnect the battery, because you've now got 2 live terminals here. Okay, move that out of the way for a moment. So this is our motor. Now it looks like you can't actually change anything in the way of brushes. Right, so what we want to do is check across these two terminals here, okay, and check continuity across there. Now if it's, what we should have is a very low resistance, okay. If it's anything other than that, then the chances are the motor is broken. So again, the old meter comes out, put it back on resistance, okay, and the sort of reading we want to get is something very low like that, okay. Obviously not too low because it will be a dead short. So, oh, let's do this the right way around, not that it makes any difference. One on that side, one on that side. We've basically got an open circuit, okay. So across the motor we've got an open circuit, which means something is not connected in there, possibly the brushes. Also, because it's a DC motor, if you put that on voltage, okay, if you spin this, you should be able to generate a little bit of voltage. But basically, nothing going on there. Okay, you can see that's making some difference, but it's actually, I probably generate more than that. This is me, I'm generating electricity. Can you even see that? Look, that's me. I'm so charged. Right, let's see if we can see anything in here without actually taking it apart. Right, I'll set up a little experiment here just to check to make sure that what we're reading is actually correct. Now I've got one of my good, sturdy Stanley Fatmax batteries. It's got 2 lights on it. And all I've done is literally taken 2 wires off of that. Okay, so in theory, I should have 18 volts on here. Okay, 19.8. So I've got myself a little power supply here. Now in theory, if I put it straight to the motor here, I've got it mounted in the vise. This should go whee. Okay, don't touch these together because it will get sparky. That's on the negative. Yeah, absolutely nothing. Okay, that should be spinning like Billy-O, but it's not. So let's get this apart. Right, see if we can see anything in there. Right, so we're looking inside as much as we can because you can't really take it apart. Okay, if we turn it by hand, we can see the, if you see the little brassy bit there, or coppery colour bit, that's the commutator. That's where the brushes actually contact the motor. Okay, so if I can get in there. Now I'm using a cocktail stick because obviously I don't want to be shoving metal in there. Okay, so that bit there that my cocktail stick is touching, that's the commutator, and this bit here is one of the brushes. Now I've just had a look and it seems like there's only one brush, but on the other side there seems to be a metal tag. Okay, let me see if I can show you. Right, this is all handheld and it's a bit shaky. If you look there on the commutator, you can see there's just a metal tag. Let me turn it around so you can see what contacts. Okay, and again, oh, I'm so wobbly. Right here, that bit there, it's like a metal tag. So it seems like there's one brush and one metal tag. Okay, and it looks like that metal tag is literally worn away. Okay, that is never going to work. Let me draw you a quick picture of that to show you what's going on. Right, I won't get too complicated about this, but basically the commutator that we're looking at, so the little coppery round bit at the end of the motor, okay, like this, okay. What you normally have is you have 2 brushes. You have one brush this side and one brush this side. Okay, these go off to your battery. Okay, and what happens is the current goes through here and generates, it basically generates a magnetic field and the motor turns. We're not worried about that at the moment. We're interested in this contact here and this contact here. Okay, now it looks like this motor has got one brush, which is fine, but on the other side it looks like instead of having a brush, it's just got a metal strip that runs along it like this. Okay, so this is connected here, so this spins around and it actually just contacts on that metal strip. Okay, but it looks like what's happened is this metal strip is worn away. Okay, so we now have that, but that's not actually touching. Okay, so it doesn't matter how hard we try, we're not going to be able to fix that. So this means it needs a new motor, but it proves the rest of it is okay. So what I'll have to do now is find out how much a motor is, and then leave it disassembled. And then if we get a new motor, we can pop that in and job's a good one. So we know what's wrong with it. All right, so we now know what's wrong with it. The problem is you can't get into it to actually do any repairs. I probably wouldn't want to repair it anyway because it does spin at quite a high rate of knots. Okay, so what we're going to need is a new one of these. Now, if you look on here, it's actually got a number. It's worth making a note of that number. Then you could probably find a replacement. We know what's wrong with it. I think that's all I can do for tonight. So we now know what's wrong with it. Obviously, we've got to get a new motor. I can't repair that tonight because obviously I don't have a spare one. My dilemma now is whether I put it all back together or whether I leave it apart. Now the problem is I don't know how long it will take to get a new motor. So when I go to put it back together, am I going to remember how it goes? Okay, for how long it's going to take, I may put it back together, find out how much a motor is, find out the person who owns it, whether they want to replace it. Okay, it all depends on price. It may be cheaper to buy a new unit rather than just a new motor. Okay, but that's another day's problem. Okay, I hope you found this video interesting, just so you could see the internal anatomy of this hedge trimmer. As I say, it's the Makita DUH523 Hedge. Okay, I think that will do for tonight. Thank you very much for watching, and I'll see you in the next video. Bye. You have to move out of the way. Oh, for God's sake. Right, found it. Here it was, hiding under a bit of rag. That's loose. Ugh. That's that. Right, so this is the basic anatomy of a DHD. Let's try that again. Oh, come on. Should have got Stanley.